Hello everyone. Here's a video regarding quantum computing in a very simplified manner. This is not for those who have a strong understanding of quantum computing or physics background. Let's begin. Quantum computing is unlike standard computational work, which uses qubits. Your classical or normal day-to-day life computers that we use, they use bits, and quantum computers use qubit. This is the first basic difference. So what is a bit? A bit is just like an on or off switch. Means it will either be on or off. Means it will respond like a bit is just a microscopic light switch. It can be off or on. Everything you do on your normal mo- mobile phones, your laptops, tablets, even I'm recording this video. This is built out of millions of the simple zeros and ones. Whereas in quantum computing, we use qubits. What are qubits? They are your quantum bits. They are your quantum bits. It can exist as 0, 1, and simultaneously both as 1 or 0. And in my previous shot, where I explained about those specific points, one was superposition principles. And what is a superposition? Let me give you an explanation. You think of tossing a coin. When you toss a coin, or when a coin is on a table sitting flat, you either get a head or a tail. Fine. But you cannot get a state which is simultaneously both when the coin is lying. This is the classical bit system. It is definitely head or definitely tail. Fine. Then what a qubit is? Now think of that coin which is spinning now. It is not lying flat on bed, it is spinning now. It is simultaneously exhibiting the both head and tail. Got it? Hope you understand. While spinning, the coin is not strictly heads or tails, it is a blend of both at the same time. Simultaneously, it exists in both the states. It only becomes a definite heads or tails when you slap it down. Fine. So, now come to quantum computer, the application part. The quantum computer can process massive amount of possibilities simultaneously. It is not restricted to this or this, but to a superposition of the both. I will give you an example of this. Suppose here your father is here and your mother is here. Both are here. Fine. And suppose simultaneously your father wants tea and mother wants newspaper, and there is a person who is working at your home. Suppose what this person does, once this person goes, gives the tea, then once again it hands over the newspaper. This is the classical system. Now what is a superposition type of system? This person, what he will do, he will hold the cup in one hand and the newspaper in other hand, and wait a minute, he will hold the cup in one hand, newspaper in one hand, and it is going to deliver both simultaneously. Fine. Now, there is another aspect. There is entanglement. What do you mean by entanglement? You think of playing Ludo? Imagine two normal dice in separate rooms. Their outcomes, when you are rolling them, their outcomes are completely independent. Fine. Now, what is entanglement? Entanglement is like this. Even if they are millions, billions of kilometers apart, right? Now imagine quantum entangled dice. No matter how far apart you take them, If one dice rolls 6, the other will roll 6. If one rolls 1, or the other will roll 1. And this is automatic and simultaneous. At that moment, if one dice rolls 6, at the very moment, automatically the other dice will roll 6. I will give you an example here. Like, suppose you two very close friends are there, and someone hits at you, and your friend automatically strikes him down. Why? Because you share a kind of feeling that this is my friend, this is my friend. Or something happens in a family also. If someone tells something to your father and you get furiated, because this is just a logical explanation. This is not exactly quantum entanglement. Hope you understand. Now, come to the application part. Quantum entanglement links qubits together. So when you add more qubits, you don't make it linearly faster. You don't make the quantum computer linearly faster. You make it exponentially faster. Then there is another phenomena. There is quantum interference. What is interference actually? You all, if not all, at least you know about noise cancelling headphones. Oh, nowadays it is cheaply available in noise cancelling earphones around 1500 2000 rupees. Fine. So what they do, they send a opposite signal to the noise they receive. So they cancel out. Something kind of that happens here. What I have taken an example here. You are looking for one specific key hidden inside 1000 locked boxes. I repeat, you are looking for one specific key hidden inside 1000 locked boxes. What a regular computer would do, it would open the boxes one by one until it finds the key. A quantum computer would do? A quantum computer creates a web that checks all 1000 boxes simultaneously. Right? The web paths leading to the 999 boxes. This is 999. Don't make it like AAA. This is 999. To the 999 boxes. Uh, and they destructively interfere because they will not find the key there. The web paths leading to the 999 boxes hit each other out of sync and cancel out. That is called destructive interference. Those who have read your 12th, 11th, 12th physics properly have an understanding of this destructive interference. But to explain someone who is not from a science background, let me tell you it like this: two opposite waves coming towards each other and cancelling each other. The wave path leading to the one right box hits in sync and boosts itself, and this is called your constructive interference. The, so instead of a normal computer, in a quantum computer, in one go you are going to find the key, whereas in those in a classical computer, it would count 1 2 3 and it might take up to 1000 times. This ability of a quantum computer, it can take medical science to the next level. Let me explain how. Suppose we are trying a we are testing a drug on patients, and we are collecting the data. A quantum computer can execute this processing in days, which would take a normal computer 1 year or 10 years. Fine. We'll discuss quantum computers later. This is a very simplified explanation of how a quantum computer behaves and the basic phenomena associated with a quantum computer. Hope you understood. If any questions, do comment.